Hi everyone, welcome to my YouTube channel. So today I am going to explain B versus H curve, that is called hysteresis curve or BH curve. So my dear students, today I am going to explain with the graph also. So here I have to draw and I have to show in the graph. So please listen to me and then please follow my YouTube lecture and also please subscribe. So if you want to subscribe this video, so now only you can subscribe. Now this is BH curve apparatus. This is BH curve apparatus. So here the resistance varies 0.1 ohms and 1.0 ohms and 10 ohms. So here the capacitance is 4.7 microfarads. So here already the connecting wires. So we have given connecting wires according to the circuit diagram. So here what is the aim? To determine B versus H variation and also the hysteresis loss. How much hysteresis loss by using the apparatus. This is CRO. So this is CRO. So we have to draw the BH curve in this CRO. So right. So now these are the switches. So according to CRO and BH curve apparatus, so we will give the right connections and also so here this is on and off. So after giving the connections, the BH curve appears like this. The curve will be appears like this. So for the varying of different resistance. For example, I will put the wire in the resistance 0.1 ohms. So here the curve comes like this. So here the curve comes like this. So here this is channel 1 and channel 2. So you can check. So where the BH curve means on x-axis the magnetic field intensity and y-axis the flux will be appears. So here saturation magnetization appears. So if the field intensity increases, the magnetization reaches the high value. So if the field decreases, it reaches to retentivity. So again the field increases in the opposite direction, it reaches to coercivity. So the particular field is called coercive field. So again the field increases in the positive direction, it reaches to saturation magnetization. So what is meant by magnetic material? The material which can be magnetized by the application of external field. So what is meant by magnetization? The process of converting non-magnetic material into magnetic material, which is called as magnetization. So here by using magnetic material, so you can draw the BH curve. How the field intensity will be given to the particular material and then so how the graph shows the flux, how the flux varies according to the field intensity. So that shows in this CRO, that is called as BH curve. So right. So here, so first we are giving 0.1 ohms resistance, then we will give 1 ohms resistance and also we can give 10 ohms resistance. So first I am giving 0.1 ohms resistance, then the BH curve appears in the CRO. So coming like this. So here this is BH curve. So now we have to plot in the trace paper. So now we have to plot in the trace paper. So here coming like this. Right? So here this shows BH curve in the trace paper. So for how much ohms? R equals to 0.1 ohms. For R equals to 0.1 ohms. So similarly we can change the resistance. We can put in the 1.0 ohms. Here 1.0 ohms. Then again the graph comes in CRO. So now we can adjust channel 1 and channel 2. So we must draw the complete cycle. So coming like this. Yes, right? So again, so coming like this. So how much resistance? R equals to 1 ohms. For R equals to 1 ohms, coming like this, BH curve. So for R equals to 0.1 ohms, coming like this. For R equals to 1 ohms, BH curve coming like this. So this is the most important thing. So first we must draw the BH curve in the trace paper. Okay. So then you can take signal length in x-axis. How much? For example, x-axis, so 2.2, and also y-axis 3.4. So here, so this is the circuit diagram of BH curve. So according to the circuit diagram, so in the apparatus also we have shown. So coming to tabular column, so input resistance. So first one is input resistance. So how much is input resistance? We are giving 0.1 ohms. So horizontal how much? So here for 1 ohms. So here 0.2 or 0.3. So here 5. So that you can write here vertical volts and horizontal volts. Similarly, area of the loop. So how can you draw the area of the loop? Then you can take graph paper. So previously I have drawn in the trace paper. So for R equals to 0.1 ohms and 1 ohms, then you can take normal graph sheet. So you must draw in the graph sheet. So here this is x-axis and this is y-axis. So here plot like this. So plot like this. Okay. So here, yes, right. Then again for 1 ohms also you can draw by using the trace paper. So coming like this. So R equals to 0.1 ohms, R equals to 1 ohms. Okay. So now again for 10 ohms also. So change the resistance 10 ohms. So previously we have taken the values for 0.1 ohms and also 1 ohms. So coming to 10 ohms. So here 10 ohms. The wire has given to the 10 ohms resistance. So that okay. So coming like this. Okay. So R equals to 10 ohms. So again take this value here and again draw in graph sheet, normal graph sheet. So R equals to 10 ohms. So here, so what is the proof? So here you can pin the trace paper. So like this. So for the evidence of different resistance, we have drawn the BH curve by using CRO. So by using CRO. So here R equals to 0.1 ohms, R equals to 1 ohms and R equals to 10 ohms. So here now you can take you can calculate area of the loop. You can calculate area of the loop. So how can you calculate area of the loop? So here take the boxes. Here take the complete box. Now plot the box. So how many boxes? So here one complete box. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So for 0.1 ohms resistance we will get 14 boxes. So each box contains 28 squares. So 14 into 28. So you can calculate 14 into 28 into 10 power minus 4. Into 10 power minus 4. Okay. So in terms of meter square. In terms of meter square. So into 10 power minus. Similarly for 1 ohms, draw the squares. So you can count the squares. You can count the squares. So complete square. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So for 1 ohms, 9 squares. 9 squares are coming. So 9 into 28. You can calculate 9 into 28 into 10 power minus 4. So similarly for 10 ohms. So 1, 2, 3, 4, 5, 6. So 6 into 28. So 6 into 28 you can calculate into 10 power minus 4. Into 10 power minus 4. So this is the calculation for area of the loop for different resistance. 0.1 ohms, 1 ohm resistance and 10 ohms resistance. So whereas coming to, so final one, so according to the tabular column we are writing input resistance and sensitivity, horizontal and vertical. So and also area of the loop. Area of the loop. And also hysteresis loss. How can you calculate hysteresis loss? By using the formula energy loss equals to 0.5 n into south sensitivity. Sensitivity in the horizontal, sensitivity in the vertical into area of the loop. So this is the formula for energy loss. This is the formula for energy loss. So sensitivity of the horizontal, sensitivity of the vertical and area of the loop. Then you can multiply it with 0.5 n. So that comes to energy loss, and then you can write here and you can take the average value and write down here. So right now I have explained, so what is the BH curve. So what is the BH curve? So comes like this. Right, my dear students? So coming like this. Okay. So BH curve for different resistance. So we must draw in trace paper and then you can plot on graph sheet. So then you can tag here for the evidence. And also you can calculate the values, area of the loop and hysteresis loss. Finally you can take the average and post here. Thank you one and all. So if you like this video, please like, share and subscribe my YouTube channel. Thank you one and all.